Hi, I'm Philip Kessner. Welcome to third part of tutorial on instrument cards, this time about converters and switches. Bear in mind that this is already an advanced topic, where not only understanding of previous topics is required, but also a fair bit of practical skills with Calibre. So if you just stormed through Calibre tutorials up to this point, take a break and try practicing what you've learned. If you are a Calibre veteran looking for new features and possibilities, keep on watching. The motivation behind converters and switches is that not every meter or source can be calibrated directly using only the standard. For example, clamp meters. There are no calibrators designed specifically for them, so you usually use a current source and a coil, which is a perfect example of a converter. Converters and switches are instruments that doesn't generate nor measure any signal. That's why you can't add them in Procedure Wizard, by the way. The difference is that converters can affect signal, for example the coil multiplies current signal, and switches can't. Let me show you a practical example. I'll create a procedure with M151 high current calibrator, which can go up to 120 amps with high precision. The problem is that accurate multimeters can't cope with high load. You see? At this point, I'll omit some calibration points which are not necessary for this tutorial. Good. If I select 1.8 amps calibration point now and mouse over the meter, Calibre will warn me that the meter doesn't have any suitable range. To cut the range of M151 to meters level, I'll use a current shunt as a converter, response manual, control manual, connect to master bus, and meter to shunt. You could connect it the other way around too, this as a shunt bus and this as master bus, but the calibration points are always applied to master bus, so eventually it wouldn't work. Okay, let's run the procedure. I'm using manual control so you can actually see that the meter switched automatically to voltage function to match the output of the shunt. And it works great! Just before we get to instrument card setup, I'll introduce you to switches. The lowest ranges of M151 are actually far too low to use 1 mΩ shunt, so it's better to connect the M151 directly to meter's current terminals. This procedure is very short, so it's okay to rewire the instruments manually, but using manual instruments in longer procedures means that you run the procedure, wait for 10 minutes till it gets to some point, rewire the instruments, run the rest and wait another 10 minutes, rewire again. Inconvenient. You can use a hardware switch instead. Let's assume I have a very simple switch with serial port. If you send it message A, it connects input and output directly to work like a cable. If you send message B, input is connected to shunt force terminals and output to sense terminals. Here in lower ranges, I will remove the shunt and connect the meter back to master bus. By the way, even here you can see how things in Calibre work in a hierarchical way, saving your time again. Now that we have a switch in place, Calibre won't prompt me with message connection scheme changed. So if M151 and the meter were set to remote control, the procedure would be fully automatic. I would just click run and walk away. Meter function is now current DC, we don't use any shunt. HP reads 270 mA. M151 source is the same. And watch this. The switch has been switched to shunt mode via serial port, and I didn't get any reconnection message whatsoever. This is the point of using Calibre, to make the procedure as automatic as possible. Now the instrument cards. I'll start with the switch, which is a bit simpler. There are no source settings, no meter settings, even no converter conditions. It's all set up at switch tab, where the switch uses two different macros for two different ranges. Really simple. The shunt uses global and source tab because in fact it's a source of resistance. A very simple source of resistance actually, as it's just a single value, but you can still set specifications for DC, AC and so on. Single value of the shunt means that you don't need Calibre to switch it on, off, check the value or anything, so manual control settings are all set to automatic evaluation. Converter conditions say that we are converting current to voltage using value of resistance. Value of resistance is always the same, so theoretically you could pass void as a converter and multiply input with a fixed value. However, that wouldn't include any uncertainty of the shunt, so it's better to do it this way. Try using simple option as much as you can, so you can actually see what you are doing in this formula box. These were the basics of converters and switches. To get more practice, try creating your own sample procedures and use F1 help if in doubt, or leave us a comment, or send us an email. Thank you for watching this tutorial. If you are keen to become even more experienced in Calibre, check the concluding video 5.